Thank you very much for having me. I'm not great at speaking off the cuff, so I'm going to read to you, but I hope it'll still be engaging. I'm going to tell you a little bit, I'm Rachel Greenberg, Objects Conservator at the National Air and Space Museum. I'm going to tell you a little bit about one of the gallery renovations I've been working on. And we just saw some images from Paul. I'm not going to talk about the engine, so I didn't want to step on his toes. The Smithsonian National Air and Space Museum, or NASM, opened to the public on the National Mall in Washington, D.C. in July 1976. The new museum was a huge success, with the 5 millionth visitor entering only 6 months later, and it continues to be one of the world's most visited museums to this day. The collection contains important artifacts from the history of aviation and space exploration, many of which have been on continuous display since the museum opened. With such a high number of visitors expecting to see these iconic and historically significant artifacts at any time, NASM has had little opportunity to change existing galleries apart from routine maintenance. In 2013, the initial planning stages for a full renovation of NASM began, which included 2 major elements: revitalization of the building, consisting of refacing the exterior cladding and replacement of outdated mechanical systems, and transformation of the exhibitions by updating all 23 galleries and presentation spaces. The transformation project has provided an opportunity for the artifacts to be removed from display and undergo thorough examination, documentation, and preservation treatment for the first time in many years. Apollo to the Moon was the first gallery to close to the public in December 2018, with plans to reopen as the newly designed Destination Moon Gallery. Many of the NASA artifacts created during the space race and Apollo eras have been on display since before museum practices were generally applied to modern aerospace materials. Little was known about the longevity of the materials when these artifacts were placed on exhibit over 40 years ago. And preventive conservation was not prioritized as part of the display techniques, which are not considered on par with museum standards of today. While many of the artifacts were manufactured to withstand the harsh environment of mission requirements, it turns out that they were not designed to withstand the test of time. These artifacts were deinstalled and brought to the Stephen F. Udvar-Hazy Center, the museum's second location in Chantilly, Virginia. While the design for the new Destination Moon Gallery had already been completed, it was not until each object was examined that a full understanding of its condition and display requirements could be determined. This necessitated close communication and collaboration with curators, designers, and exhibition specialists to properly conserve each object, keeping within a tight deadline, and to establish the ideal display methods for maintaining their preservation. The case studies in this presentation will discuss the issues and challenges in caring for such a specialized collection of unusual materials found in Apollo-era artifacts, as well as highlight the complex processes and decision-making involved in preparing these unusual objects for exhibition. These include an engineering model of a lunar orbiter spacecraft, a command module simulator instructor operator station, and a developmental Apollo helmet and spacesuit. These objects can be viewed in the new Destination Moon Gallery, which opened to the public in October 2022. Lunar Orbiter was a NASA project consisting of 5 spacecraft that mapped the moon in preparation for the Apollo lunar landings. The spacecraft were built by the Boeing Company for NASA's Langley Research Center and were launched between 1966 and 1967. Using a photographic subsystem to take real photographs and develop them on board, the lunar orbiters were able to provide high-resolution images of 99% of the lunar surface, as well as the first picture of the Earth from the moon. The lunar orbiter in NASM's collection is an engineering model originally used for testing on Earth. While previously on display, it was hung from the ceiling just outside the entrance to the museum's restaurant. When the lunar orbiter was deinstalled in 2017, conservators were able to examine it for the first time since being accessioned by the museum in the 1970s. The most apparent issue was the amount of dust that had accumulated in the recesses due to the complicated shape of the artifact and the rigging cables that made routine cleaning difficult. Recognizing that the orbiter would be suspended from the ceiling in the new gallery, where dust accumulation would be inevitable, encouraged the investigation of possibilities to prevent this from reoccurring. The investigation and research phase of the project revealed that the original flown orbiters were covered with aluminized mylar thermal blankets, while the engineering model at NASM was missing its blankets. The idea of recreating and attaching similar blankets could aid in the preventive conservation by helping to protect the artifact from future dust accumulation. A restoration of this sort required discussion with and approval from the curator, as it would alter the appearance of the artifact and possibly change the information being presented. Discussion of the thermal blanket with the curator was met with optimism, as the blanket could also help to portray the original appearance of the lunar orbiter. While the initial idea was to fashion a blanket out of new materials, the curator advised on potentially borrowing a blanket from a similar artifact in the collection. This revealed that one of the blankets from another orbiter in storage would fit around the back of the display artifact without concealing the internal components that are integral to showing the visitor how the orbiter worked in space. Since borrowing components from other objects is not typical practice, the thermal blanket that was removed from the orbiter in storage was fully documented and recorded to ensure that the original association would not be lost. While the Velcro hook tape on the thermal blanket was stable enough to allow attachment to the spacecraft, the deteriorated Velcro loop tape on the spacecraft would not support the blanket's weight and therefore was no longer a suitable attachment. A removable magnetic system was developed to attach the blanket to the spacecraft without using the deteriorated Velcro. With the help of a sheet metal specialist, aluminum sheet attachments were fabricated and connected to the spacecraft with existing bolts along the top frame, and new bolts added to existing threaded holes along the bottom frame. Rare earth magnets were adhered to the sheeting with an acrylic resin. Steel washers wrapped in muslin were sewn along the top and bottom edges of the thermal blanket instead of magnets to prevent possible tangling. The thermal blankets could then be easily attached to and removed from the spacecraft. This thermal blanket turned out to be both a solution to a problem and an added benefit to the proposed exhibition. By bringing the initial ideas to remedy the cleaning issue to the curator, the collections and curatorial departments were able to work together to create the ideal solution for the artifact. Since the lunar orbiter had been on exhibit for so long without a thermal blanket, and the second orbiter frame was hidden away in storage, the idea to display the artifact with a blanket was not in the original exhibition design. The collaboration between conservators and curators led to an updated display that is both safer for the artifact and more informative for the visitor. As with any large project, changes are inevitable. The lunar orbiter, originally planned for Destination Moon, will now be featured in the Milestones of Flight Hall, which is currently being renovated and is due to reopen in 2024. Flight simulators were an important aspect of spaceflight missions, training astronauts to manage their spacecraft through every possible situation. The command module simulators consisted of a mock-up spacecraft capable of simulating all types of flight conditions that the crew would encounter, including malfunctions inserted by simulation engineers running the simulator operator stations. The command module simulator and operator stations used at Kennedy Space Center were transferred to NASM in 1975, where they were placed in storage at the Polly Garber facility in Suitland, Maryland. Since NASM does not have an exhibition space large enough to hold the entire simulator, only the central console of the instructor operator station could be displayed in the new gallery. A thorough condition assessment of the console revealed that the artifact needed more than just a deep cleaning, as it exhibited neglect from previous storage environments and use. While soiling, corrosion, and flaking paint could be easily dealt with by a conservator, treatment of damaged interior wiring and missing control panels required consultation and collaboration with specialists to devise the best treatment approach. Discussion with the curator influenced the treatment and determined that the console would be conserved to provide an authentic and historic artifact to museum visitors, interpreting the object as it was after operational use, without completing a full restoration. The goal of the project undertaken by NASM differed from the simultaneous effort by NASA to restore their historic Mission Control Center in Houston to its 1960s functionality. The intention of the NASA restoration was to accurately portray how mission control looked at the moment of the moon landing on July 20th, 1969, while console arrays that were upgraded during the space shuttle era were restored to their Apollo 15 configurations, representing the height of technology during the Apollo missions, thus bringing the mission operations control room back to life for visitors to the Johnson Space Center. While NASM did not conduct a full restoration on its operator station console, the museum's conservator preserved historic elements that were not part of the original construction, but were authentic to the Apollo era. Attached to the underside of the writing surface is a photograph of an actress from the June 8th, 1969 Florida Today newspaper. A little internet research revealed her acting role in the contemporary short film Blame It on Florida. Tape borders remain from other newspaper clippings, but the paper elements were removed at some point in the past. These elements give the sense that a real person used this console as a workstation and were therefore preserved in situ as part of the conservation project. While treatment of NASM's console did not intend to make it operational, stabilization included accounting for broken and missing parts. Conversations between the conservator and curator about how these elements would affect the appearance of the artifact and the story that the curator was aiming to tell resulted in removing anything structurally unstable that would not be visible while on display. The broken light bulbs, detached electrical cables, and various loose hardware found inside the console were removed, photographed to document their manufacturing specifications, and placed in collection storage. While removal of elements from inside the console would not affect the outward appearance, the missing instruments and buttons from the control panel did visually affect the presentation of the artifact and the story that it told. Replacement of these instruments was considered, but the deadline for the project would not allow the team to secure the correct parts. However, an entire missing section from the control panel detracted from the overall appearance. Hence, the idea of a graphics panel was devised to visually suggest the presence of the missing instrument control panel. To create a graphics panel, the curator conducted research into the missing elements. The original schematics for the control panels were located and loaned to the museum by the Center for Technology and Innovations. The museum's exhibit production specialist took high-resolution scans of these schematics and printed the missing panel schematic onto a display board that was inserted into the open space. While the printed graphic does not portray real buttons and instruments, it allows the viewer to interpret the original functionality of the panel with the understanding that the original components are no longer present. The decision to conserve the simulator operator station in its current state rather than restore it was only possible through collaboration. As a museum artifact, it was important to conserve the console in a way that allows it to inform museum visitors about the technology and training methods used during the Apollo era, while preserving the evidence of its use beyond that time. Apollo-era spacesuits, along with components such as gloves and helmets, were designed to provide a life-sustaining environment for an astronaut during extravehicular activity or unpressurized spacecraft operation. The materials used to create the suits were selected for their ability to provide strength and stability during the mission and were not intended for long-term display in a museum. When the materials are new, they provide the characteristics necessary for living and working in space, such as mobility, temperature regulation, and pressurization, but they do not have good aging properties. The primary goal for conservation of spacesuits and their components is to stabilize and preserve the original materials, ensuring that any evidence of use is retained. Before spacesuits could be safely used in space, experimental suits and prototypes were created for rigorous testing on Earth. A selection of 3 developmental suits, 2 of them with their respective gloves and helmets, were selected for the Destination Moon Gallery, each with their own condition issues and complex materials. A developmental Apollo helmet and spacesuit will be presented here. The SPD-143 Apollo prototype helmet was manufactured in 1963 under the first contract between Hamilton Standard and the Specialty Products Division of the International Latex Corporation, or ILC. A condition examination of the helmet revealed two concerning condition issues: deteriorated polyurethane foam and cadmium corrosion. Polyurethane is a complicated material that has proven difficult to maintain and preserve in museum collections. The polyurethane foam inside the leather cheek pieces was actively crumbling and spilling into the main body of the helmet. Since this foam would not be visible on display, the most important aspects of the treatment were to preserve the foam from continuing to spill and to physically support the cheek pieces where they appeared misshapen and hollow due to the collapsed foam cells. The crumbled foam was removed using a HEPA filter vacuum, and the remaining foam was consolidated using a dilute acrylic resin. After consultation with the curator to discuss the appearance of the cheek pieces, the hollow areas were bulked and reshaped using polyester batting inside cotton stockinette. The areas of unraveled stitching and tears in the leather were covered with archival silk adhered with an acrylic dispersion to prevent additional foam from spilling out. Besides improving the condition of the material, the treatment maintained the original appearance of the helmet, thus preserving the authenticity of the artifact. The helmet's second significant condition issue was cadmium corrosion that formed on some of the hardware. Cadmium plating is an essential coating used in military and aerospace technology that is applied over base metals to act as a sacrificial coating, corroding under adverse conditions, preferentially to the substrate. However, once the cadmium plating deteriorates, it forms a toxic corrosion product, identifiable as a yellow-green powder, which must be appropriately treated to prevent a safety hazard. Having dealt with this material on numerous artifacts within NASM's collection, the conservation team collaborated with industrial hygienists at the Smithsonian to develop a methodology for treating artifacts with this issue. Discussions about the significance of preserving evidence of the cadmium plating while also removing the health hazard allowed conservators to determine a path forward. The health risk was reduced by keeping the corrosion wet during removal to inhibit the powdering material from entering the air and causing an inhalation concern. This method allowed for the removal of the hazardous corrosion while preserving the non-friable layer that had not yet become a risk. By working together, conservators and industrial hygienists were able to devise an effective strategy to preserve evidence of the original material as best as possible, minimize health risks, and ensure the artifact remains intact for museum visitors to enjoy. The A5L developmental suit was manufactured in 1966 as the fifth out of 7 generations of Apollo spacesuits made by ILC Industries and was submitted to NASA as a precursor to the lunar suit. The unusual blue color of this suit is actually the pressure assembly and restraint layer, typically located under the white micrometeoroid garment cover layer of later lunar suits. A condition assessment of the suit revealed that it was in relatively good condition compared to many other early suits. Some of the condition issues, such as small tears in the textile, only required documentation, while others, such as corrosion on the hardware, required minor treatment. Most of these condition concerns are common aging and degradation issues that conservators face regularly. What made the treatment of this suit more challenging was the deterioration of the polyurethane rubber boot soles. Originally, the rubber would have provided cushioned yet strong support for the boots. After being in storage for years, where climate control can slow but not prevent the degradation of synthetic polymers, the rubber exhibited elevated levels of deterioration. Most of the material was missing, and what did remain was actively crumbling. Conservation of the boot soles required discussions with the curator to decide on the most appropriate treatment. Stabilization could easily be accomplished by consolidating the material, but the degradation would be visually distracting, and the boot soles could face further damage from abrasions caused by future handling. Since the deterioration of the rubber was a result of inherent vice of the material and not due to use, a treatment was devised to stabilize the remaining rubber, aesthetically reintegrate the material, and prevent any potential future degradation from becoming visually distracting. The crumbling rubber was consolidated with a dilute acrylic dispersion and encapsulated with Japanese tissue adhered with a water-soluble adhesive. The shape of the boot soles was recreated using ethafoam with an outer layer of painted cotton blotter. These materials were attached to the encapsulated rubber using an acrylic adhesive with additional Japanese tissue. The adhesives were selected based on reversibility and retreatability. If necessary, the tacky acrylic dispersion will allow the outer layers to be mechanically removed, while the water-soluble adhesive will allow removal of the inner encapsulation layer without disturbing the consolidated rubber. This treatment maintained the original material of the boot soles in a way that will allow retreatment if research produces new methods and best practices in the future. Until then, discussions between conservators and curators led to a treatment in which reconstructing the soles created a more informative experience for visitors, allowing them to see the suit as it was originally intended. Once the helmet and suit were treated, mounting was taken into consideration to help maintain the preserved condition. Working with the museum's textile conservator and the exhibit's fabrication specialist, customized mounts were created to relieve stress on the sensitive materials. The helmet was mounted on a plate connected to the neck ring. To avoid pressure to the fragile polyurethane cheek pieces, a head form was not fitted to the interior of this helmet. A discussion with the curator concerning a lack of air circulation through the plate, potentially causing a buildup of harmful pollutants caused by off-gassing materials, led to the decision to display the helmet with the visor open. This allows for increased ventilation and for visitors to better see the interior of the helmet. The spacesuit was fitted with a customized ethifoam mannequin designed to provide support and maintain the correct shape of the suit. The external stand connected to the mannequin alleviated any stress from the treated polyurethane rubber by slightly lifting the suit up and preventing the weight from resting on the boot soles. In this case, collaboration between conservators and mount makers was necessary to maintain the exhibitable condition of the spacesuit and components. The spacesuit and helmet were then ready for installation in their climate-controlled case, where deterioration due to inherent vice of the materials would be slowed, ensuring their preservation. This multidisciplinary approach to conservation of Apollo-era artifacts and the larger space history collection at the National Air and Space Museum has proven essential for their preservation. Conservators at NASM are fortunate to have colleagues in specialized departments to provide expertise and contribute their unique skills. Collaboration between conservators, curators, restoration specialists, gallery designers, exhibition mounting specialists, and industrial hygienists has proven crucial in devising innovative techniques and best approaches to treating these historic and sensitive artifacts. The conservation of Apollo-era artifacts for display in the Destination Moon Gallery has allowed for an informative and engaging museum experience, from displaying stable artifacts to providing accurate historical context. These artifacts are an important part of American history, and therefore it is essential to continue fostering collaboration, ensuring the preservation of the Apollo era for future generations. Thank you.